All right, I think I'm recording. We'll find out later. So we are taking a look at the fraction addition modeling. Now it says fraction addition and subtraction right here, but I didn't actually give you any subtraction problems. We'll do some later. So this is just going to be addition for now. And we're going to start off with the color strips representing 1/6 plus 1/3 with the dark green being a whole. So you have the toys in front of you if you want to play with those, if you didn't already draw it out. So this is one whole right here, and it's good to have these in order nearby, or at least a picture of them. And the dark green one is the 6th one, so that should be made up of 6 individual white pieces. And we need to look at what is 1/6 plus 1/3. So which piece is 1/6 of this whole? The white one. So that's 1/6. Then which piece is 1/3 of this green whole? Which one?
Red.
The red one should be 1/3. And if we're not sure, we can make a train by it. Train is when we put them end to end and make sure that 3 of them make a whole, so one of them is 1/3. I got a weird shadow there. All right. So let me snap this shot, this to draw it. Pull those out for now. So this is an illustration of 1/6 plus 1/3. And what can we do to demonstrate the answer? So we can kind of look and guess at the answer. What is it?
Half.
What is it? A half? Yeah, it looks like it's covering 1/2 of it. All right, we should confirm that. So to confirm that, I whip out some more toys. And I grab the piece that's half of that. And so I can see that, yeah, one of those halves matches up. Okay. Is there another way to answer this question besides 1/2?
36.
Yeah, we could look and say, well, let's make these more similar, so we could replace the red. Oh, interesting. That disappeared. Oh, okay. Huh. And weird technology stuff going on. Stuff is disappearing on me. Yeah, so 1/6 plus 1/3 we can see is 3/6 also. So that's another way to look at it. Let's add that. We can also see it's equal to 3/6. So a couple different ways to look at it. And so the activity was just playing around with different toys to model this. So let's take a look at that pattern blocks. And I wanted you to make a sketch of it also. So we want to show again what is 1/6 plus 1/3. With pattern blocks. Attempt to draw one whole here, and then 1/6 of that. If we say that piece right there, and what piece makes a good third? In the pattern blocks, what is 1/3?
Rhombus.
Yeah, so there's a rhombus. Thank you. So there's the 1/6 and 1/3. So remember, addition means combine and count, so I'm going to combine and put them together. And get a new one. draw it. So I have to put that green one in. Let's say I'm going to stick that over here. And then the rhombus goes right there. So here's my green triangle, my best colored lines, and my blue rhombus. So there's two ways to view the answer here. I could break everything up with green triangles and talk about 3/6 as the answer. Viewing this one right here, it looks pretty clear that that's 1/2. So one answer is 1/2. Or if we just look at it in terms of green triangles, we get 3/6 too. So if we think about a common denominator on this, looking at those two separate pieces we had, what common piece makes up both my 6th and my 3rd? The triangle, right? Yep. So when I look at it that way, I'm rewriting this with the green triangles as the 1/6 is 2 triangles. Ooh, I lied. What is the 1/6? 1 triangle. And then the 1/3 could be viewed as 2 triangles. I can spell today. Again. So that's the 1/6 plus 2/6 gives me the 3/6. Is it possible to use a smaller denominator than 1/6? Well, sorry, yeah, smaller. Will a smaller denominator work? Like, is it possible just to use thirds as the denominator and still get an answer? No. So 6, I think, is the smallest denominator I can get away with. Okay. Can we simplify the answer, though, even with the smallest possible denominator? Yeah, it still simplifies, right? So this is just an important thing to note about fractions. So will a small denominator work? The answer is no. 6 is the smallest denominator here. But still, the answer reduces. So just because you have a smallest common denominator doesn't mean you're free from reducing. That's just an important thing about fractions. We'll come back to that again and again. All right, let's try this problem one more time with drawing our own square cakes. So that was part 2. Part 3 of this activity was to use square cakes. And the procedure I gave in the example that I went over last time is, and we want to show 1/6 plus 1/3. So I draw a square equal size to the best of my ability underneath each of these. And I cut one of them vertical and the other horizontal. So let's say I'm going to cut this one vertical. So draw your best sixths and shade one of them. And since I went vertical on that one, on the other one, I want to draw horizontal. So make your best shot at thirds horizontal and shade one of them.
Can we also talk about D on that one?
Yep. And add means combine and count, but we can only combine and count things that are like, and these aren't like. So the trick was cut each cake like the other. So now I go back and I cut the sixths into thirds and the thirds into sixths. And there are many ways to make the cuts. This procedure just works all the time. We'll talk about other procedures. So now I've broken this into a grid that's 3 by 6. So what's my denominator now? 18, yeah. So then I just rewrite underneath what I have. I have 3/18 in this one. And in this one over here, looks like I have 6/18. Altogether, I can count out that that gives me 9/18. There's 9 shaded pieces altogether. So let's redraw that. So I want you to draw another hole, cut into 18 pieces, and put all 9 shaded pieces in there. So draw that new same sized hole. Cut it into thirds one way, cut it into 6 the other way. The best of your artistic ability. It varies from moment to moment. Did you guys get any toys back there? And then throw those 9 shaded pieces in there. Can we rewrite the answer based on that? Now I can't put them exactly where they were before because there's 2 pieces that are trying to occupy the same location. So you can distribute them in there any way you want, but there's got to be 9 of them. So I might go 1, 2, 3, 4, 5, 6, 7, 8, 9. You could stack them that way. There's lots of ways to throw them back in there. But that new one is the answer, right? I'm accounting for each of the pieces. Can you see a way to regroup those 9 pieces to come up with a different answer?
1/2.
Yeah, one possibility is we just look at that and say, hey, this group right here makes up 1/2 of the whole. That's one way to do it. I was looking at that and thinking there's one shader on red. There's 1, 2, 3 groups of 3 there out of a total of 6 groups of 3. So I was seeing 3, 6. So those are the 2 main ways to look at least this one right here. What's the best answer?
Top one.
Yeah, usually 1/2 when it's totally reduced is considered the best answer, but they're all good answers. They're all right. All right, let's redraw that one. Oh, no, actually, somebody asked a question about a different
D.
part. D, let me see, what was D?
3/2 plus 2/3.
D, 3/2 plus 2/3. Excellent. Okay, let's try to do it. So we're sticking with, oops, wrong one, my one page. There we go. 3/2 plus 2/3 using the cake model. All right, so let's do 3/2 first. So that says I have to show 3/2. Now, one issue there is when I draw my first hole, I can only show 2/2. So what do I have to do? I got to draw another hole. Yeah. So I have to draw another hole to go with that. Ooh, it's not quite the same size. Let's try again. Oh, wrong button. And again, you want to try to make them as close as you can to the same size. A little bit better. Yellow, so there's 1. Oops, that's red. 2. There's my 3 halves. So we have mixed numbers to contend with also. And then I want to combine that with 2/3. And once I pick a direction for one cake, the other cake gets a different direction. So that one's vertical, this one has to go horizontal, make your best thirds. And then we want 2 of those. All right, next step, cut each like the other. So this one I'm going to cut in half, and these guys get cut in thirds all around. So to combine them together, we need to know 2 things. How many shaded pieces are there all together here? Shaded pieces. There's 6, 7, 8, 9, 10, 11, 12, 13 of them. So there's 13 shaded pieces out of what in a whole? 6 in a whole, yeah. So based on the cakes, the answer when we combine and count is 13/6. There are 13 equal sized pieces, 6 of them make a whole. So remember, the numerator means just count. Denominator means what are you counting? And fractions are equal parts of the whole. So you have to know how many parts are in a whole. So there are 13 equal parts of a whole. There's 6 pieces in one whole. So 13/6 is one answer. Can we come up with another answer? Yeah, so how do we draw that though? So it's just like the way I was trying to come up with a better answer here by taking those pieces and putting them together into a new whole. So we're just going to regroup our stuff and see what happens. So I'm just going to make a note that this is equal to, and I know for sure that I need one whole for the first group of stuff. I'm going to need a second whole for sure. And those have to be cut in thirds and half in each direction, so I get 6. And then I just want to keep track of each of them. So that one goes there, that one goes there. So just keep track by either marking them off or just counting them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I'm so close. Oh. 13. So redrawing it, and let me just outline these a little different. Shaded them different. Shows us that 2 1/6 is another answer. Which is the better answer? 2 1/6? Why?
It's not an improper fraction.
What's wrong with an improper fraction? Nothing. Yeah. So the answer to the question, which one is better, is kind of a loaded question. It depends is the answer. Now, back in this previous example right here, sometimes 9/18 is an okay answer, but it's usually easier to work with fractions that are as simple as possible. And 1/2 is way simpler than 9/18. So 1/2 is definitely the better answer here. But over here, it's a totally different scenario because 13 and 6, nothing divides into both of them. It can't be reduced. Right? This improper fraction is reduced. And we'll see when we're doing some more calculations with fractions, if you need to do another calculation with the number, 13/6 is a better answer. If you need to explain it to somebody, like they need to do something with it, like give directions, or maybe it's a measurement, 2 and 1/6 in conversation makes more sense. So it just kind of depends. But they are both reduced, they are both simplified, they're kind of equivalent, but they just have different uses. But I can't get away from 6. I'm stuck with 6 here. In the previous problem, 18ths could get simpler to 6, or halves, I can't get any simpler than halves. Halves is the smallest number in the end. Okay. Let's try, I think that's about the hardest problem there. I'm going to give you a few more minutes to tidy this up. I'm going to pause the recording. Do that.